In junior forms, we have learned 5 basic trigonometric identities. In senior forms, we can still apply these 5 trigonometric identities even though we have extended the concept of trigonometry to any angles. In addition, in senior forms, we need to know a lot more trigonometric identities. However, there is no need to memorize all of them, as we already know the concept of reference angle and cast rule. If we can apply these 2 concepts, we should be able to derive all the trigonometric identity results on our own. Now we will take a look at 4 examples of how to simplify trigonometric ratios by considering the reference angle and the cast rule. For cosine 90 degrees plus theta, it is not equal to cosine 90 degrees minus theta, so you cannot simplify this into sine theta directly. Instead, we should consider the coordinate plane, and 90 degrees plus theta can be illustrated by this. That is 90 degrees and then plus theta. This is 90 degrees plus theta. And that means this one is the reference angle that we need. And this reference angle should be equal to 90 degrees minus theta. And in this quadrant, according to the cast rule, cosine should be negative because only sine is positive. Therefore, we can conclude that cosine 90 degrees plus theta is equal to minus cosine of the reference angle. And the reference angle is 90 degrees minus theta. We have already learned that cosine 90 degrees minus theta can be simplified as sine theta. And therefore, the answer for this one is minus sine theta. Let's take a look at the second example. For sine 180 degrees minus theta, we do something similar. First of all, we consider the terminal side of this angle 180 degrees minus theta. This is 180 degrees. And minus theta means we want to rotate this clockwise. So that is 180 degrees minus theta. And the reference angle is this one, which means the reference angle should be equal to theta in this case. And now we can conclude that sine 180 degrees minus theta is equal to, in this quadrant, according to the cast rule, sine is positive. Therefore, this is equal to plus sine of the reference angle, which is theta. That means sine 180 degrees minus theta is exactly equal to sine theta. In the third example, we need to simplify tangent theta plus 270 degrees. First of all, we need to realize that this one is equal to tangent 270 degrees plus theta. And now on this coordinate plane, we can locate the terminal side like this. This one is 270 degrees and then plus theta. That is 270 degrees plus theta. Therefore, the reference angle is here, which is equal to 90 degrees minus theta. And in this quadrant, according to the cast rule, only cosine is positive. That means tangent is negative. And therefore, this expression is equal to minus tangent of the reference angle. And the reference angle in this case is 90 degrees minus theta. In junior form, we have learned that tangent 90 degrees minus theta can be simplified as 1 over tangent theta. And that means the answer for this one is minus 1 over tangent theta. Finally, let's take a look at how we should simplify tangent theta minus 180 degrees. First of all, we should treat this to be equal to tangent minus 180 degrees plus theta. By doing so, we can locate the terminal side in this way. Minus 180 degrees means rotating in a clockwise direction. So this is minus 180 degrees, and then plus theta means rotating in an anti-clockwise direction. So this one is minus 180 degrees plus theta. Therefore, the reference angle is here. This is a reference angle. And this alpha reference angle should be equal to theta. And now in this quadrant, according to the cast rule, tangent is positive. Therefore, this expression is equal to positive and then tangent of the reference angle. And the reference angle is theta, so that means that's plus tangent theta. Therefore, we can conclude that the answer should be simply tangent theta. To conclude, once we can apply the concept of reference angle and the cast rule, we should be able to come up with all these results easily.